A hospital doctor once described the hypothetical situation this way. Imagine a patient is wheeled in, a 200-kilogram individual who has been completely motionless for 5 months, eating nothing, drinking nothing, producing no urine whatsoever. You run their blood tests, you expect organ failure, you expect toxic waste levels that would indicate the kidneys have shut down entirely. Instead, everything is normal, blood chemistry clean, muscles intact, bones strong. No bed sores, no blood clots, no kidney damage. The patient simply stands up, fully functional, slightly annoyed, and walks out. That patient is a bear, and what happens inside its body during winter hibernation is one of the most extraordinary biological mysteries scientists have ever tried to unravel, with implications for kidney disease, space travel, and the future of human medicine. What happens to a human without urination? To understand why the bear is so remarkable, you first need to understand what urine actually is, and what happens when you stop producing it. Your kidneys filter your blood constantly, removing waste products that build up as a normal byproduct of your body breaking down protein. The main waste product is a compound called urea. Left in the blood, urea becomes toxic. Without the kidneys removing it continuously, urea builds up in the bloodstream, leading to a condition called uremia. And uremia, untreated, is fatal. In a human being with complete kidney failure, toxic waste levels become dangerous within days. Without dialysis or a transplant, death follows within weeks. The kidneys are not a luxury organ, they are a non-stop filtration system that your body cannot survive without for long. A bear stops urinating for up to 6 months, every year, and wakes up fine. Something fundamentally different is happening inside that animal, and it took decades of research to begin to understand what. The urea recycling system. During hibernation, a bear's kidneys do not shut down completely. They slow dramatically, filtering blood at roughly 1/4 of their normal rate. But the tiny amount of urine they do produce never leaves the body. Here is where it gets extraordinary. The bear's bladder wall becomes permeable during hibernation. Instead of holding urine as a storage tank until elimination, the bladder reabsorbs everything back into the bloodstream. Water is recovered to prevent dehydration. Electrolytes are recovered to keep the blood chemistry balanced. And the urea, the toxic waste that should be poisoning the animal, is shunted to the gut, where specialized bacteria break it down and convert its nitrogen into amino acids. Those amino acids are then absorbed back into the body and used to build muscle protein. The bear is not just surviving without urination, it is turning its own toxic waste into building material. The poison becomes the fuel. The body runs a closed loop of nitrogen recycling, so efficient that after 6 months without eating, drinking, or eliminating, a bear's blood urea levels are actually lower during hibernation than during the active summer months. This is the opposite of what happens in any known human condition involving kidney failure. When human kidneys slow, urea climbs. When bear kidneys slow, urea falls, because the waste is being harvested and reused before it can accumulate. What the bones and muscles are doing, the urine story is extraordinary on its own. But the bear's hibernation biology doesn't stop there. Consider what happens to a human who is completely immobile for 6 months. Muscles waste away within weeks. Bones begin losing density within days. Astronauts spending months in zero gravity lose between 1 and 2% of their bone mass every single month, even with exercise protocols specifically designed to fight it. Bed sores develop, blood clots form in the legs from poor circulation. The body begins breaking itself down. A hibernating bear does none of this. Its muscles stay intact. Researchers taking biopsies from bears in the middle of hibernation found that muscle fiber numbers and cross-sectional area were essentially unchanged from the active season. The bear is not exercising, it is barely moving. Its heart beats as slowly as 8 times per minute. Yet its muscles show almost no atrophy. Its bones do the same. Bone is constantly broken down and rebuilt even in healthy adults. A process called remodeling. During hibernation, bears suppress bone breakdown while continuing bone formation, meaning their skeleton is actually maintaining itself without any mechanical loading from movement or weight bearing. When they walk out of their dens in spring, their bones are as strong as when they walked in. Scientists believe this involves a finely tuned hormonal system. Changes in parathyroid hormone, vitamin D metabolism, and growth signals that somehow tell the skeleton to hold firm even during months of complete inactivity. The exact molecular pathways are still being studied. What is not in doubt is the outcome. A bear emerges from half a year of motionless sleep with a body in better condition than a hospitalized human after 2 weeks of bed rest. The medical revolution waiting in the den. Kidney disease affects around 14% of adults in the United States and over 20% of the global elderly population. When the human kidney is damaged, that damage is typically permanent. The only options are lifelong dialysis or a transplant. There is no drug that repairs kidney tissue. There is no treatment that makes a failing kidney regenerate. Bears may hold the key to changing that. Researchers at the Karolinska University Hospital in Stockholm, studying bear hibernation for insights into human medicine, described the hibernating bear as a metabolic magician. The mechanisms by which bears prevent toxic waste buildup, prevent muscle wasting, prevent bone loss, and prevent blood clots, all simultaneously, all without medication, all driven by genes that have evolved over millions of years, represent a complete biological solution to problems that human medicine has not yet solved. If scientists can identify the specific proteins and gene signals that activate the urea recycling system, they may be able to engineer probiotics that help kidney failure patients process their own waste more efficiently. If they can isolate what suppresses muscle breakdown in bears, they may be able to develop drugs that protect bedridden patients or ICU survivors from the muscle loss that currently makes recovery so much harder. NASA is actively studying bear hibernation as a potential model for protecting astronauts on long-duration space missions to Mars. Both the bone and muscle loss during weightlessness and the possibility of inducing a hibernation-like state to reduce the psychological and physical demands of a journey that could take 9 months each way. A bear sleeping in a den in Alaska is, without knowing it, running the most sophisticated biological experiment in medical history. The bear wakes up every spring, somewhere between March and May depending on the latitude, and the animal stirs. It stretches, it blinks in unfamiliar light, it walks out of the den a little thin, slightly groggy, ready to eat enormous quantities of food to rebuild its fat reserves before the following winter. 6 months without food, water, urination, or defecation. Muscles strong. Bones intact. Kidneys functioning. Blood chemistry normal. Scientists have been studying this for decades and still cannot fully explain it. They know the broad strokes: the urea recycling, the permeable bladder, the hormonal changes in bone, the suppression of muscle wasting signals. But the complete picture of how a mammal whose biology is far closer to ours than most people realize, achieves this without any apparent cost or consequence, remains one of the most fascinating open questions in all of biology. The bear doesn't know it's doing something impossible. It's just surviving winter. If this completely changed how you see hibernation, subscribe and hit the bell. There's a new story every week. Drop a comment which part surprised you most, the urea recycling, the bones, or the muscles. See you in the next one.